Hello everyone. I hope all of you are doing fine. So I welcome you all to my 10th video lesson of for the class 9 physical sciences. Right? So without any further ado, let's start our today's class. So students, yes students, what you saw or heard in this video rather, yes students, when the drum is getting beaten, so it is producing some type of sound, isn't it? It is producing sound, right? So students, this sound is produced when this drum is getting beaten. Okay students, now let's see this video. Have you done this experiment? If you have a steel scale, you can place it on the table and then make it vibrate like this. It will go zing, right? So it will produce a sound. So when you will hear that sound, is there any relation between this means movement of the body and sound production? Yes? What do you think? Okay, students, right. So now let's do an experiment to prove this, right? So here is a tuning fork, right? And this tuning fork was struck, right? So this tuning fork was struck with a hammer and it started to produce sound, right? So what was observed that this pitch ball is getting moved to and fro, right? This ball started moving. So how it is possible that a sound this tuning fork is getting beaten and the ball started moving here. So we can say that there is some vibration in the sound, right? So students, we set the objects vibrating and produce sound, right? So there cannot be any sound without vibration. So what is vibration? Vibration is nothing but vibration is just to and fro motion of an object, right? So vibration is just the to and fro motion of the object, right? So when we hear the voice of us ourselves, so here in our neck there are vocal cords, right? There are two vocal cords like this made up of cartilage, and when the air is passed from below, so those cartilage vibrate and produce sound, right students? Yes. Okay. So students, let's see about this bumblebee. Okay, you might have seen this type of bee and it produces a sound, isn't it? This bee produces a sound. So the bee produces a buzzing sound through the quick movement of its wing, right? When it flies, right? So even the bee will produce more sound when it will produce its wing and the thorax, right? So this is the wing and this is the thorax portion. So when it will move its wing and the thorax, so it will produce more sound. Yes, students? Right. So when the crow, suppose there is a crow and he flaps his wing gently, then there is production of little to no sound, right? So we can say that sound is produced only by the rapid to and fro movement, or we can say vibration of an object. Okay, students? Right. So now we have studied how the sound is being produced. So now there is a quiz for you. So the first question of the quiz is, sound is produced because of what? The sound is produced because of, okay, I'll give you 5 seconds to think about this question. Okay, so what will be the answer of this, students? Right. So the answer will be sound is produced because of the vibrations, right? It is produced because of the vibrations, right? And how does we hear the sound of buzzing bee, students? I'll just give you 10 seconds to think about this question. Yes. So we hear the sound of buzzing bee because the bee is moving its wing in rapid to and fro motion, right? It is moving its wing in rapid to and fro motion, and from that motion only the sound is getting produced. Okay, students? Right. And we will hear more sound if the bee starts to vibrate its thorax also, right? So then we will hear more sound, right? So now let's proceed ahead. Students, can you see what is happening in this picture? Yes, students. Okay, so this person is beating a drum, right? So this beating of drum is producing a sound, and that sound is reaching towards us. So have you ever wondered like how this sound is reaching towards us? We already saw that to produce a sound, we need to produce vibration. So vibration is nothing but the rapid to and fro movement, isn't it, students? Yes. So to produce a sound, we need to produce rapid to and fro movement, and that rapid to and fro movement, what it will do? It will produce sound. Right. So now let's study how does the sound propagate. And by the meaning of propagate, I mean to say that we will study how that sound reaches to us. So when we take our example only, you might be seeing this video on your laptop or on your phone, isn't it? Yes. So there is a speaker present in your laptop or on your phone or in your earphone. So when you that speaker or the earphone or the laptop is producing the sound, right? So that sound needs to travel through something to reach to us, isn't it? So we will see how does the sound travels, or rather we can say we will see how does the sound propagates. Okay, students. So now let's start. So students, you can see from this picture that there is a tuning fork B and A, right? So what it is happening, what is happening in this picture? So this tuning fork is moving in rapid to and fro movement, right? It is moving in rapid to and fro movement, and due to this rapid to and fro movement, what is happening? There is a compression and a rarefaction happening. Okay, students. So what is rarefaction? Rarefaction is that the molecules of the air are getting separated more, and compression is what the molecules of the air are getting pushed together, right? So there is compression and rarefaction happening here, right? So by the means of this compression and rarefaction, this sound reaches from this tuning fork into our ear. Okay, students. So now let's see how this compression and rarefaction occurs. Okay, students. Let's see. So a wave of disturbance that moves through a medium when the particle of the medium set neighboring particle into the motion. So see, this is the normal case, means it is the a case where nothing is happening. So when we struck it, so this tuning fork is getting what? This tuning fork is getting deviated, right? So this tuning fork is getting separated like this, right? So when it is getting separated, what it is doing? It is pushing the air that is present near it, right? So we can see here it is the compression, right? So now what will happen? These compressed group of air molecules of the air will start to push the next section of the air, right? So we can see that it has transferred its energy to here, and it has again reached into the rarefaction state, and here it is the compression state, right, students? So now this way only the sound will propagate outside, right? So we can say that a wave of disturbance that moves through the medium when the particle of medium set the neighboring particle into the motion, right? So they turn in and produce similar motion in others, right? So this is producing a similar motion in the other molecules also. The particles of the medium do not move themselves. So it is very important to note that the particles of the medium do not move, but the disturbance is just carried forward. Okay, students? So this compression and rarefaction wave is just carried forward, right? So this is what is being done in the propagation of the sound. Okay, students? So now let's proceed ahead. Students, you can see that here is a boy and here is a boy, and this boy is tapping the table, right? So the sound is traveling, okay, students? The sound is traveling from this direction to this direction, right? So it is traveling through solid also, right? You are, if you are listening this video on your mobile or on your laptop without using any headset, then the sound from the speaker is reaching your ear through the air only, right? So we can say that the sound can propagate through air, sound can propagate through water, and sound can propagate through solids also, right? So students, now we will see that can sound propagate without any medium. So here is an experiment, right? So in this experiment, what is being done? There is nothing special. So this is a bell jar, okay? This is a bell jar and it is a vacuum tube, right? So it is a vacuum pump attached to this bell jar and there is an electric bell. So we all know that when an electric bell will ring, it will produce some type of sound, isn't it? So, students, when we connect the electric bell to the power and turn its switch on, it will start to produce sound, right? But as soon as we start to vacuum this jar, the air inside this jar is getting pulled outside. So when the air is getting pulled outside, then what is happening? We won't be able to hear any sound, right? So we can say that the sound waves can propagate through the medium, right? The sound waves can propagate through the medium, but they will not propagate without any medium. Okay, students? So the sound waves can propagate through the medium, but they will not propagate without any medium, right? So now let's move forward. So there is a quiz for you guys. So you need to tell me how does the sound propagate, and for your help I have pasted this picture also here. So use this picture and tell me how does the sound propagate. Okay students? Right. Yes. So we saw that for the sound to propagate, what is happening? There is a disturbance, and that disturbance is causing the disturbance in the other molecules also, right? So the particles themselves are not changing their position. They are doing what? They are just vibrating in their positions. So when it is vibrating in this position, it is transferring the vibration in this molecule also. So in this way only the sound is getting propagated. Okay, students? Right. So that is the answer for this question. So now let's move ahead. Students, what you can see in this picture? Yes, you can see that in this picture there is a waves, isn't it? There are waves. We have all saw this type of waves in our daily life. Okay, so we can even see this. We can do an experiment also. We just need to place water in a bucket, okay, and keep it there for some time so that it settles down. And after that, just drop something into that water. You will see this type of ripple waves being carried all across the water, right? So is it only in water or does the sound also have any this type of waves? Yes. Okay. So now let's see what is there in the case of sound. Okay, students. So students, there are basically two types of waves. Okay. So these are longitudinal waves and the transverse waves, right? So as we see that energy is transported in this direction and the energy is transported in this direction and the movement is also in this direction. So this is called as the longitudinal waves, right? So in the second case, in this picture, when you will see, we will see that the energy is transported in this direction but the source moves up and down, right? So this is the transverse wave. Okay students, right? So longitudinal waves travel by compression and rarefaction, and transverse wave travel by crest and trough. Okay students, right? Okay, even this longitudinal wave can be represented by crest and trough. Okay students, so now let's move ahead. So basically, there are two types of wave, longitudinal waves and transverse wave. So longitudinal waves are those waves in which the particles of the medium move parallel to the propagation of the wave, right? So like the propagation of sound, sound is what? Sound is a longitudinal wave, right students? Okay. So now when we will see that what type of wave is this type of waves, right? So these are called as the transverse waves. Okay students, what we call them? We call them transverse waves. And why we call them transverse wave? Because the source move in a perpendicular direction to the movement of the particles. Okay, students. So the transverse waves are those waves in which the particles of the medium move in perpendicular to the direction of the propagation of the waves. Understood, students? So how many types of waves are there? There are basically two types of waves. First is called the longitudinal waves. Another one is called the transverse wave. So in the longitudinal waves, the movement is in the same direction, movement of particle in the same direction in the propagation of the wave, and in the transverse wave, uh, the particles of the medium move in a direction that is perpendicular to the propagation of the wave. Okay, students? Right. So now let's move ahead. Yes, students. So we saw in the first case, the particle moves parallel to the wave, and in the second case, the particle moves perpendicular to the wave. We can see the energy is being transported this side and the particles move in this direction, right? So the first case is known as what? The first case is known as longitudinal wave. Example is the sound wave, and second wave is known as the transverse wave, or we can say light wave, right? So wave is traveling forward, but the particle is moving up and down, right? So that is called as the transverse wave. Okay, students? Right. So now let's move ahead. So students, tell me, light is a transverse wave. Is this statement true or false? Light is a transverse wave. Is this statement true or false? Right. So light is a transverse wave. Yes, students, light is a transverse wave and sound is a longitudinal wave. Okay, students, light is a transverse wave and sound is a longitudinal wave. Okay. So the next question is, the particle movement is in longitudinal wave is the particle movement in longitudinal wave is parallel to the wave propagation or perpendicular to the wave propagation. Yes, see, read this question very carefully. Particle movement in the longitudinal wave is parallel or perpendicular to the wave propagation. Which is correct? Yes. So in the longitudinal waves, we have seen that the particle movement is parallel to the wave propagation. Okay, students? Right. So now let's quickly recap what we have learned in our today's class. So we have learned that the production of sound, propagation of sound, and the type of wave in our today's class, right? So now who will explain how the sound is produced? Okay, right. So now see, we saw in our today's class that sound is produced when there is vibration. And what is vibration? Vibration is nothing but rapid to and fro movement. Okay, students? Right. So let's describe the production of sound by the bumblebees. Okay. So the bumblebees have wings, and what they do, they try to flap those wings, right, as fast as possible, right, to keep them in flight. So due to the rapid to and fro movement of their wings, a vibration is created, and that vibration makes us hear the sound. Okay, students? Right. So how can we explain the propagation of sound? So propagation of sound occurs by the means of compression and rarefaction, and the compression and rarefaction occurs due to what? This occurs due to the disturbances. And one important point to note here is that the particles never leave their places actually. What they do is rather they just transmit the disturbance to the neighboring particle. Okay, students? Right. So how we can differentiate between the longitudinal and the transverse wave? Yes. So in the case of longitudinal wave, the particles will move in a parallel direction to that of the propagation of the wave, right? But in the case of transverse wave, the movement of the particles will be perpendicular to the direction of the movement of the wave, right? So as we saw in the case of sound, there will be compression, and then there will be rarefaction, then again there will be compression, right? So this is the longitudinal wave, right? So here in the longitudinal wave, we can see that the particle is moving in the same direction as that of the wave, but in the transverse wave, the particle is moving in a perpendicular way, right? So that wave will be like this. Okay. So how we can define mechanical waves, student? So mechanical waves are the waves that can cause disturbances, right? So longitudinal waves and the transverse wave, these all are example of what? These all are the example of mechanical waves. Okay, students? Right. Now this is your homework. What you need to do is you and your friend are on the moon, and will you be able to hear produced by your friend without any aid? So this is your first question. You need to research this, you need to find this, and you need to write the answer. Okay, students? So second is that you will explain how the sound is produced by your school bell. Okay. And third question is that why are the sound waves called the mechanical waves? Okay. So this is the homework for you guys. So let's end our today's class here only. So that's all for today, students. Thank you. Have a nice day.